Hey guys, hope you're doing well. Today we're going to go through some harder practice examples with these formulas that we've talked about a few times now. And the reason is because I've seen so many people struggle to take these to the next step that I just want to show you guys and have some practice with you to help you for when those inevitable harder problems come along. So again, let's go through these formulas that I hope you've memorized by now. It's really important that you keep practicing with these because they are so important and you can't solve any of these problems if you don't know them. So first one is the intersecting chords formula. Obviously self-explanatory. If two chords intersect, that's when you use this one. And it says that the parts of one chord can be multiplied together and set equal to the parts of another chord. So the parts of the chord 1 we'll say are A, and B, so we can multiply A and B, and that has to give you C and D. So that one's probably the most basic. Now the second one is the secant formula. So here you have to know what a secant is, which is a line that goes through 2 points on a circle. So you can see that a chord just connects 2 points, but the secant is going through it. It's continuing in this direction right here until we get to this external point. And the secant formula applies obviously if you have two secants, but they have to meet at the same external point, and that's this point that I just drew in here. So they're meeting at that point, and that's when I can use this rule, which says the length of the entire secant 1, so we'll call this secant 1, so we have part A, that's the length of the whole secant, multiplied by the external part, which is part B, right here, that's the external part, it's the part going from outside the circle to the external point. So you multiply those together, and that has to equal the other secant, same thing, so the entire length of that second secant multiplied by its external part, those have to be equal. So again, not bad. Hardest part is just identifying, is this a secant, and what is the external part? For external part, just think it's the part that's outside of the circle. External is out of the circle. So really closely related to the secant formula, we have the secant tangent formula, and this is when we have a secant and a tangent, but they're also joining at the external point right here. So they have to join at the same point for this to work. And then again, we take the length of the entire secant, so B, multiplied by the external part of that secant, which is C. Then it equals A, which is the tangent length, squared. So A is just the length from the external point to the point where the tangent touches the circle, because as you know, a tangent only touches the circle at one point. So that's that length that we need to square. So it's basically A times A equals B times C. And now we're going to get into some harder examples. So I recommend you pause the video after you see the problem, like right now, and then try to do it yourself, and then we'll go through how I would do it. So always the first step I do is I figure out, well, what am I working with? What situation? Is it a secant? Is it a secant tangent? Is it an intersecting chords? So let's figure that out. So I see that this first one, I'll call this line 1, is a secant because it's going through the point here. It's going through the circles at this point, but then it's continuing. So this is a secant. And now my second line that I have, I'll call this line 2, is doing the same thing. It's going through the circle here, going through the circle here, and then it's continuing in that direction. So it's a secant problem. Okay, and now I know that I'm going to need to figure out the length of the entire secant because that's part of my formula. I need the length of the entire secant, and then I also need the length of the external parts. So entire secant and external parts. And remember, the external parts are the parts that are outside of the circle. I've said that a few times now, but just to make sure. So the length of the entire secant would be from here all the way to here. That first point all the way to the last one. And for our first secant, it's pretty easy. It's just 6 plus 6, so that's 12. So 12. And then the length of the external part, the first one has an external part of 6. But now let's look for the second one. So the length of the entire second secant, you got to be careful here because this is the entire second secant, but this x is just the part connecting those two lines. So it's going to be 8 plus x will give you the length of the entire secant for the second part. So, and I'll put that in parentheses for the second one, 8 plus x. Okay. And now again, it's external part. Well, that's just the length from the circle on the outside of the circle to the other one, and that's 8. Now I need to multiply those parts together, and they will equal each other. So for segment 1, we had 12 times 6 equals, well, the second segment is going to be 8 plus x, because that's the length of the entire thing, times 8, which is the external part length. Now I'm going to simplify. 12 times 6, as you know, is 72, equals, now here you need to distribute, so we need to take that 8 to both parts. So 8 times 8 is 64 plus 8x. And now this is looking good. Just subtract 64 from both sides. I get 8x equals 8. And that means, well, x equals 1. So that's how you solve that problem. So a little tougher, but if you go step by step and you know your rules, it's nothing to be too worried about. You can handle it. So next one. So this one, I've got a lot of stuff going on. Again, I recommend you pause and you really take a second to try to figure this out. We have two variables going on. We have y and x, and we need to somehow figure out both, I'm sure. So for the first one, I see that I'm given a chord here. This is a chord, obviously, because it's joining 2 points. I see that I've got a secant here, like from here to here. And I've got a tangent from here to here. So we have truly all 3 parts going on. So there's a lot of different rules that we can do. But if I use the secant right here, the only secant we have, I would have to do the secant tangent rule, right? So secant tangent. But I see this secant has 2 variables in it. So I'm not going to be able to get an answer out of that secant tangent rule. I need to find something else. But what I see is that I have to somehow use this chord probably. But I have a chord, and I also have an intersecting chord right here. Even though this is part of a secant, there's a chord here. This part that joins the 2 points on the outside of the circle, well, that's a chord. So I can go to my intersecting chord formula, and I'm going to have to use that first because I only have one variable within that. I only have x. The y is not part of the chord. So intersecting chord formula says that I can multiply the parts of one chord and set it equal to the multiplied parts of another chord. So the multiplied parts of this chord right here, I'll call that 1, or 12 times 2. So I have 12 times 2 equals these parts of the other chord multiplied together, which is x times x plus 2. So now we just solve for algebra. We do the algebra to solve for the x. So 12 times 2 is 24 equals x. Now I need to distribute x times x and then x times 2. Be careful with x times x. A lot of people want to say 2x, but it's actually x squared. You got to be careful with that. So we get x squared plus now x times 2. Now that's when you get 2x. So we get 24 equals x squared plus 2x. And now is when you have to know, well, how do I solve this? This is a quadratic, so I need to factor. And to factor, you get everything set equal to 0. So what I'm going to do is I'm going to subtract the 24 from the other side. And I'm going to get x squared plus 2x minus 24 equals 0 because I subtracted 24 from both sides. So now I'm looking for a number that can multiply to negative 24, 2 numbers, and add to positive 2. And I see, well, that's going to be positive 6 and negative 4. So I'll get x plus 6 and then x minus 4. And that equals 0, and then you set each factor equal to 0. So if x plus 6 equals 0, x equals negative 6. If x minus 4 equals 0, x equals positive 4. So those are my 2 answers. And now we need to think, well, how can there be 2 answers to the problem? Well, one of them is not going to work. And take a second and try to figure out which one. Well, it's going to be the negative 6. So this, we cross that out because that can't be a solution. And if you think about it, the reason why is because this length can't be negative. You can never have a negative length. That just doesn't make sense. So it's got to be 4. So x equals 4. Okay, now that's only half the problem. We also have to do the secant tangent rule that we noticed early on in the problem. So secant tangent rule says that if I take the length of the tangent and square it, so 8 squared, that needs to equal the length of the entire secant, which is this whole thing. Sorry, that was really badly drawn. The whole length of that secant, which I know now, I know the x, but I don't know y. So let's plug in these x values, and I'm going to erase this x, and I'm going to put 4, right? And instead of x plus 2, I'm going to put 4 plus 2, which is 6. So now I know that length. Okay, so I have a squared equals the length of the entire secant, which is this length here, like I said. And now I know, well, that's going to be 10, because that's 4 plus 6 plus y. So 10 plus y multiplied by the length of the external part, which is going to be y, because that's this length right here. And again, I have another situation where I'm going to need to solve this out. So 64 equals, again, now I need to distribute. So 10y plus y squared. I'm going to subtract 64 from both sides. Minus 64, and that'll cancel, and I'll get y squared plus 10y minus 64 equals 0. So now we're looking for, again, numbers that can multiply to negative 64 and add to positive 10. So let's think about it. I know that 8 times 8 works. What about 4? 4 times what? 4 times 16. That won't get me to what the number I need. But so I don't think any two numbers are going to multiply together to get me that. So I have to go to the quadratic formula. So I do negative b. Remember that I'll just write out the quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. So now we need to plug in our numbers that we have. We have negative b, which is this number here, so negative 10 plus or minus the square root of b squared is 10 squared, which is 100, minus 4, and then a is the coefficient in front of y squared, which is 1, times c is negative 64, divided by 2a, which is just 2 times 1, which is 2. So I'm going to get negative 10 plus or minus square root of 100 minus 4 times negative 64, and that's going to be obviously positive because it's a negative times a negative. And then we have, what's 4 times 64? Well, 2 times 64 is 128, and then that times 2 gives you 256. So it's going to be plus 256 divided by 2. So I'm going to simplify again. I'll get negative 10 plus or minus square root of 356 divided by 2. And now this, you'll notice, this is, again, we have y equals this big thing right here. But we need to be careful again because we figured out that length can't be negative. I'm going to write that here. Length cannot be negative. And we have two solutions here, right? Because we have the negative 10 plus the square root of 356, but we also have the negative 10 minus the square root of 356. So we need to think, well, which one's going to be positive? Well, the square root of 356 is something greater than 10, right? So negative 10 plus like something greater than 10 is going to be a positive number. But then if I do negative 10 minus something greater than 10, so negative 10 minus like 16 or something, I'd get negative 26 divided by 2, which would be negative 13, which would be a negative. So this minus thing is not going to work. That's going to give us a negative answer, which can't be right. So the only y is going to be negative 10 plus the square root of 356 divided by 2. That is our only solution for what y equals. And now we have figured out both y and x. This is a very hard example. You got to know the quadratic formula, you got to know the secant tangent and the intersecting chords formula. You have to know a lot to be able to answer this problem correctly, and that's where I want to get you guys eventually. I know this may have been a little too much right now, but I recommend maybe you pause it and go back later and try it again, and I bet you'll be surprised and you'll be able to get it right. So hopefully this made sense. That's all I have for today. Let me know if you have any questions. Thanks for watching.